In this video, we're going to take a look at the difference between the stack and the heap. Thanks for watching Automate Now. I'm Marco Cruz. Let's dive in. We're going to begin by taking a look at the definition for each of these terms. The stack refers to a data structure known as LIFO, that is last in, first out. Imagine going into a buffet restaurant in which you're going to have a stack of plates. You're not allowed to take a plate from anywhere but the top of the stack. This also means that the last item to go on the stack is the first item to come off the stack. We're allowed to allocate and deallocate memory by adding or removing from the top of the stack. The heap, on the other hand, is a lot more flexible in the sense that we're allowed to allocate and deallocate memory anywhere in the heap. Both the stack and the heap refer to different areas in memory. Next, we're going to see how a typical program uses the different areas of memory. And here we have a small Java program in which we're building a video game. In this video game, we have a ninja character, and this ninja character can perform different actions. For example, it can throw ninja stars. So if we look here, we have two classes. This class is called Ninja, and we have another class called Attack. In the Ninja class, we have this main method, and this main method contains a variable called Health, which is set to 100 initially. Then we are calling a method called Fight. This method is a private method that is stored in this class. Notice that this method is creating a new instance of the Attack class. And then we are calling a method in the Attack class called Throw Ninja Stars, and we're passing the value of 3. If we look at the Attack class, it contains an instance variable called Damage Done, and it has the Throw Ninja Stars method. This method takes in one parameter called Count, and it simply prints this message to the screen. Next, we're going to have a look at where all these variables, methods, and arguments go in the heap and the stack. And in this screen, we can see our program on the left and the heap and the stack on the right. And the stack memory will contain the different frames, or the plates as in the restaurant example. This would be the first plate. On top of that plate would be another plate, and then on top of that another plate. So this would be the very top of the stack right here. And notice that the heap space is shown in a different shape here because it doesn't resemble a stack. And let's have a look at our program. Here we have the Ninja class. We're going to begin with the main method. Every Java program begins with the main method. As you can see, we have a frame for the main method, which will be the first frame right here. And notice that it has health is equal to 100. That is because this main method contains a local variable called health, and it has been set to 100. You will notice that the variable health and its value 100 are stored in the stack. And this is because int is a primitive type. All primitive types get stored in the stack. Any variable that is of primitive type will have its value stored in the stack. So now we see that the first frame is the main method. Then we see a call to this other method called fight. We can see here that this is the method right here. So a new frame with the method's name fight gets created on the stack. Now let's see what this method is doing. This method is creating a new instance of the attack class. That's why we see here attack is equal to a reference to the attack object. And this is the key difference between primitive types and reference types. Up here in the main method, we created a primitive type. But over here, we're using the new keyword. So we are creating a reference type. When we create a reference object, that object gets created in the heap. And a reference to this object is given to the local variable in the stack. That's why we see attack is equal to attack reference. This variable called attack with lowercase a will not contain the actual object. It will simply contain a reference to the object that is stored in the heap. And here we see that object being created in the heap. We see attack, which is the type of the object, and then we see damage done is equal to 0. This damage done variable is an instance variable. If we look down here, this is the other class. Notice that this variable over here, damage done, is declared at the class level. It belongs to the class. That's why it's called an instance variable. And instance variables are stored in the heap. That's why we see it here in the heap space. Let's go back to the fight method. So we created a new instance of the attack class. Next, we see attack that throw ninja stars, and we're passing the value 3. This throw ninja stars is this method down here. So this means that the stack will have a new frame with the method's name, throw ninja stars, and it's going to have count is equal to 3. The reason why we see count and the number 3 stored in the stack is because arguments that are passed to methods are also stored in the stack. And you may be wondering what happens to all these items on the stack and the heap. Well, let's go back to the program. When this method called throw ninja stars finishes execution, the frame that belongs to it on the stack will be wiped out from the stack. and that space will become available for new items in our program. And when this is done, it returns the control to this fight method. And when this fight method completes the execution, its frame will also be wiped off the stack. This also means that this reference to the attack object will also be removed. And this object over here on the heap will become eligible for garbage collection. And lastly, this will return control to the main method. And when the main method terminates, our program has ended. And the frame for the main method will also be removed from the stack. So our stack will be empty by the end of the program. I would like to end by showing you some of the key differences between the stack and the heap. As we can see here, the stack will throw what is known as a stack overflow error. So when the area of memory in the stack runs out of room, it will show stack overflow error. In the heap space, it will throw what is known as out of memory error. So this is very important to know when you're debugging your program. If you see a stack overflow, you know it's the stack issue. But if you see an out of memory error, then you know the heap has run out of memory. Also note that the space in the stack is a lot smaller compared to the space in the heap. So the stack will run out of room much faster than the heap. One advantage that the stack has over the heap is that the access time is a lot faster in the stack compared to the heap. Also, the stack is considered safer, since data is accessible by owner thread only. The heap, on the other hand, is considered less safe because data is accessible and visible by all threads. And lastly, we see that the stack is mainly used to store local variables, arguments passed through methods, and object references. The heap, on the other hand, is used to store objects, Java runtime environment classes, and instance variables. I hope that by now the difference between the stack and the heap are very clear to you. If they're not, please leave me any questions in the comments below, and I would love to get back to you.